In the last lecture, we have seen Euler's theorem, the statement. What is the statement of Euler's theorem? The value of e raised to I theta equal to cos theta plus I sin theta. And from this, we have the formulae for cos theta, sin theta, tan theta, sec theta, etc. So what is cos theta? Cos theta is e raised to I theta plus e raised to minus I theta divided by 2. What is sin theta? Sin theta is e raised to I theta minus e raised to minus I theta divided by 2I. So then the remaining trigonometric functions we can find very easily, that is sin theta by cos theta is tan theta, then 1 by cos is sec, 1 by sin is cosec, 1 by tan or cos by sin is cot, etc. And then we have seen the various formulae for trigonometry. Then the next one is hyperbolic functions. We have defined hyperbolic functions. So what is cos hyperbolic x? Cos hyperbolic x is e raised to x plus e raised to minus x divided by 2. What is sin hyperbolic x? Sin hyperbolic x is e raised to x minus e raised to minus x divided by 2. Then tan, then sec, cosec and cot we can find very easily, that is 1 by sin is cosec, 1 by tan is cot, etc. Cot hyperbolic. Then we have seen the various relation between the hyperbolic functions and trigonometric functions. Circular functions. Trigonometric functions are also called as circular functions. So one of the result is sin ix is I sin hyperbolic x, like that, isn't it? Then cos ix, tan ix, etc. The proofs of which also we have seen in the last lecture. Then we have seen the result, the cos hyperbolic square x minus sin hyperbolic square x is equal to 1. That is actually identity. So the proof of that also we have seen. Similar type of proofs also we can have. You can solve them at home. Then the next part, that is some solved examples are there. So you just see these examples. Nature of the example is using Euler's formulae, prove that cos of minus theta is equal to cos theta, cos square theta plus sin square theta is equal to 1, 1 plus tan square theta is equal to sec square theta, sin theta is 2 sin theta by 2 into cos theta by 2, etc. So how we prove this? Cos of minus theta is equal to cos theta we have to prove. So what is LHS? LHS is cos of minus theta. But we know by Euler's formula, cos theta is e raised to I theta plus e raised to minus I theta divided by 2, as I have told now, just now. Then what is cos of minus theta? Replace theta by minus theta in the above. So that becomes e raised to minus I theta plus e raised to minus, that is plus I theta, e raised to I theta divided by 2. So that again becomes e raised to I theta plus e raised to minus I theta divided by 2, which is nothing but cos theta. So this formula from trigonometry we have proved. Then the identity cos square theta plus sin square theta is equal to 1. So what is cos theta? E raised to I theta plus e raised to minus I theta divided by 2. Its square plus sin square theta e raised to I theta plus e raised to minus I theta divided by 2I. Its square. Just square this. Similar type of example as we have seen in the last lecture. So 4 is common, etc. Then only remaining thing is 2 plus 2, that is 4. The other term gets cancelled. So 1 by 4 into 4 is 1. So we have proved cos square theta plus sin square theta is equal to 1. This one. Then the next proof is 1 plus tan square theta is equal to sec square theta. This is also again an identity from trigonometry. So that also we can prove like this. LHS is 1 plus tan square theta. But what is tan theta? Tan theta is this one. then square this, and finally you will get 4 upon e raised to 2I theta plus e raised to minus 2I theta plus 2. That is 2 upon e raised to I theta plus e raised to minus I theta bracket square. But what is this? The bracketed expression is nothing but sec. So sec square theta, this square is here. So 1 plus tan square theta is sec square theta. The next result from trigonometry is sin theta is 2 sin theta by 2 cos theta by 2, which we are calling in trigonometry half angle formula. So how this prove this? The proof of this we can do? Take RHS instead of LHS. Here take the RHS. RHS is 2 sin theta by 2 cos theta by 2. So sin theta we know, and therefore theta by 2, replace theta by 2 in that, and you can get this step. Then finally we will get this step after simplification. These are all simplifications, and what you are getting, e raised to 2I theta minus e raised to minus 2I theta divided by 2I, which is nothing but sin theta, e raised to I theta minus e raised to minus I theta divided by 2I, which is nothing but sin theta. So what we have to do here, this bracket and this bracket, take the product, and the product is like this. Some term gets cancelled. The remaining terms are e raised to I theta minus e raised to minus I theta divided by 2I is here, divided by 2I, because this 2 and this 2 gets cancelled. So what is this by Euler's formula? This is nothing but sin theta, and therefore we have proved RHS is equal to LHS. That is sin theta, 2 sin theta by 2 cos theta by 2 is equal to sin theta. The next one is the next type of examples can be asked like this. Convert the following exponential forms into Cartesian forms. The examples are like this. Root 3 into e raised to this one, isn't it? So root 3 into pi, this is e raised to I theta is cos theta plus I sin theta. So instead of theta here there is pi by 6, and therefore root 3 is here, and cos pi by 6 plus I sin pi by 6 by Euler's theorem. So root 3 cos pi by 6 is nothing but root 3 by 2, sin pi by 6 is nothing but half. So what you are getting, 3 by 2 root 3 you multiply by root 3. So 3 by 2 minus I into root 3 by 2, that is x plus iy form means the Cartesian form. The next one is 4 into e raised to this one, isn't it? Here also the same thing, 3 pi by 2 is there. So instead of this 3 pi by 2 is here and minus is here. Therefore cos of 3 pi by 2 minus, because this minus I sin 3 pi by 2 minus 4 into cos 3 pi by 2 is 0 and sin 3 pi by 2 is minus 1, and what you are getting, 0 plus 4i as in the Cartesian form. Next one is, next type of examples can be asked like this. Separate into real and imaginary parts. So sin of x plus iy, tan of x plus iy, cos hyperbolic x plus iy, sin alpha plus beta formula you can use, addition formula. Sin theta cos, sin alpha plus beta, sin alpha cos beta plus cos alpha sin beta, like that. So, alpha is x, beta is iy. So use the relation between your circular function and hyperbolic function. So what is cos iy? That is cos hyperbolic y. What is sin iy? That is I sin hyperbolic y. Like this. So use these results and collect the terms which are free from I, and these are the terms which are with I. So real part is the term free from I, and imaginary part is this one. So sin x cos hyperbolic y and cos x sin hyperbolic y, these are the respective real and imaginary parts of sin of x plus iy. Then the next one is tan of x plus iy. So tan of x plus iy, you use the formula again, tan alpha plus beta, tan alpha plus tan beta upon 1 minus tan alpha tan beta. Use the relations then this multiply numerator and denominator by conjugate of denominator, and finally you will get the real part, this one, imaginary part as this one. The next is cos hyperbolic x plus iy. So cos hyperbolic x cos iy plus sin hyperbolic x sin iy. Again the same thing, use the relations between them, and the real part is this one, imaginary part is this one. The next type of examples are, if cos hyperbolic alpha plus I beta is equal to x plus iy, then show that x square by cos hyperbolic square alpha minus y square by sin hyperbolic square alpha is equal to 1. Again the same thing, you just simplify this by using the addition formula in hyperbolic functions. So you can get this one, then x is this one, real part, y is this one. Then the next one is, from this sin beta, cos hyperbolic beta is this one, sin hyperbolic beta is this one, but we know the identity from hyperbolic function, that is cos hyperbolic square beta minus sin hyperbolic square beta is equal to 1. Put these values of cos hyperbolic beta and sin hyperbolic beta, and hence we have proved the result what we want to show. Then if next type of example, cos of alpha plus I beta is equal to x plus iy, then prove that these two similar type. So cos of x plus iy is x plus iy is this one, cos of alpha plus I beta, cos of alpha plus I beta is equal to x plus iy. Again use the addition formula, use the relation between them, then find the value of cos hyperbolic beta, cos alpha, sin hyperbolic beta, sin alpha, put them in the formula we want to prove, and thus we are getting these as the answers. See, these are the examples which are frequently asked in the last question papers. If you refer the last question papers, you may find these type of questions, they are frequently asked. So be careful about this. Try to understand this. If you are any problem in understanding, please ask immediately. So with this, the example part we have completed. In the next lecture, I will give some exercise and you can have that exercise, you can solve that exercise of your own and try to solve. If you are having any difficulty, please ask. Stay home, stay safe. Thank you.